In this video, I'm going to go over our 323 homework, which was on graphing parabolas in factored form. So one thing to keep in mind, in factored form, the zeros are revealed to us, or the x-intercepts, right? So each factor gives us its own zero. So the x, or 2x, doesn't really matter how you think of it, gives us a zero of 0, and x plus 2 will give us a zero of negative 2, because it's all about what makes that particular factor equal to 0. Your axis of symmetry will always be in the middle between the two x-intercepts, because it has to do with the way that, or the symmetry of the parabola. So we know that the axis of symmetry is going to be at -1. Now, the only thing we don't know is we don't actually know the exact location of the vertex. So we're going to substitute in a -1 into our function equation. So everywhere where you see an x, we're going to use a -1. And we end up getting -2 times 1, which is -2. So when x is -1, y is -2. So that gives us this point right here. We're going to get one more value. So we're also going to substitute in a +1 so that we have 5 clear points. So basically that means that we are going to take 1 as our input and use the function rule to figure out the output, or the y value. So 2 times 3 gives us 6. So when x is 1, y is going to be 6. I'll just make it a little nicer to make it go through all the points. Okay. So now that we have this picture, we can answer all of our questions in regards to domain, range, x, y intercept. So let's go ahead and do that. Our range is going to be all real numbers, and I'm just going to use this fancy symbol so I don't have to write it out. You can totally write it out. The range is going to be all of the y values that are greater than or equal to -2. We have two x-intercepts, and we're going to write them as 2 points. We have one y-intercept and 0, 0, and it's totally okay for the same point to be the x and the y-intercept. It will happen whenever we use the origin, because the origin is a point that is on both x and y axes. Our axis of symmetry is going to be vertical line, so we know it's going to start with x equals, and the x value is -1. Our vertex is going to be -1, comma -2. It is the point where our parabola in this case is the lowest. Our min value, I'm going to circle the word min, is -2, and it is the y value of your vertex. Our parabola is concave upwards. In number 2, -5 is one of our x-intercepts, or -5, 0, right? Because it's -5 would make that factor equal to 0. -3 is our other x-intercept of the 0. Okay. We know that our axis of symmetry is going to be smack in the middle between x-intercepts. So in this case, it's going to be at x equals -4. So I'm actually going to write it right here. Now, we need to know the location, the exact location of our vertex. So we're going to substitute in a -4 into our function equation. So -4 plus 5, -4 plus 3. So let's see. -4 plus 5 is 1, and this is -1, and this gives me an answer of 1. This makes perfect sense because your parabola is concave down. When we multiply this out, we get a -x squared. And then I also want to do maybe one more point, so I'm going to substitute in a -2 back into my equation. So everywhere where my function equation has an x, I'm going to substitute that in with a -2. So -3 times 1, and we get -3. So -2, -3. Our range is going to be all of the y values that are lower than 1. X-intercepts are going to be -5, 0. and negative 3, 0. So our y-intercept is not actually on the graph, so we have to do a little bit of work. We have to use our function rule to substitute in a 0. So we're going to use 0 everywhere where we have an x. And that gives us negative 15 as our answer. So negative 15 is the y value of our y-intercept. And that is why we don't see it, because it's really, really below. Okay, so let's see what other questions we have to answer. So we also have to identify the vertex, which is just going to be negative 4, 1. We have a maximum value because we have the highest point. Our maximum value is going to be 1. And our parabola is concave down. And concave down will come from the a value, or the number in front of x squared. All right, we got 2 more things to graph, so let's take a look. And what I'm actually going to do is I'm going to graph them first, and then I'm going to shift and answer all of the questions. Because hopefully by now we're experts. So every factor will give you a 0 or an x-intercept. So x minus 5 will be 0 whenever x is 5. And x minus 3 will be 0 whenever x is 3. So let's see. Okay. I don't know what's going on. All right, so our second x-intercept is going to be 3, and that comes from this factor right here. Our axis of symmetry is going to be smack in the middle between the two x-intercepts. So it's going to be at x equals 4. Now, we don't know the exact location. We have to do a little bit of work. So we're going to substitute in 4 anywhere where we see an x. So actually, you know what? Let's do this on top of the equation because that's going to make it easier to see. So f of 4. So we're going to have 2, 4 minus 5, 4 minus 3. We end up getting 2 times negative 1 times 1, and that gives us a negative 2. And what we want to be doing is checking that everything is making sense. So this is looking like it's going to be concave up, which makes sense because we're going to end up having 2x squared if we were to multiply this out. All right, I also am interested in one more point. I'm going to be interested in 2x equals 2, because that's sort of the next x value as we move out away from the vertex. So I'm going to find f of 2, which is what I said. So I'm going to do 2. All right. So again, everywhere where we used to have an x, we're going to substitute in a 2. And we have a 2 that's multiplied by negative 3, and that's multiplied by a negative 1. And that's going to give us an answer of positive 6. And there we go. So our parabola is just a really stretchy parabola that is concave up. All right. Let's take a look at number 4, and then we're going to graph it, and then we will answer all of the questions about both of them. Before I start, what I'm going to do is I'm going to write this out so that it looks like 2 factors. And I want you to notice that both of the factors are x plus 2, which makes sense because our exponent was 2. But that means that our x-intercept is going to be negative 2. The only way we have one x-intercept would be if that is your vertex. So that means we have to do quite a lot of work to figure out what other points are on our parabola. So we're going to go ahead and we're going to substitute in a negative 1 into our function, and we end up with negative 1 plus 2 being squared, and that's just 1. So 2 times 1 is 2. So when x is negative 1, our y value is 2. And using symmetry, because remember that our parabola is perfectly symmetrical and that axis of symmetry will always pass through the vertex. The other point I would be interested in, well, the other x value I'm interested in is going to be f of 0. So f of 0 means that everywhere where we see an x, we're going to substitute in a 0. So we're going to have 8 as our output. So it's right here. And if you notice, they are quite similar in shape because they both have an x value or a value of 2. Okay, so let's take a look. So we have to answer the domain question. Domain question for all parabolas and all polynomials will always be all real numbers because we can substitute in any x value. The range in number 3 would be all of the y values that are above or equal to -2. Our range for number 4 is going to be all of the y values that are above or equal to 0. We have two x-intercepts in number 3. So those are the points where we cross the x-axis. In the fourth one, we have only one x-intercept, so we only have to list one of them. For the y-intercept, if we don't see it on the graph, that just means we have to do a little bit of work. So that means we are going to substitute in a 0 for x value into our equation. So we get 2 times 0 minus 5 times 0 minus 3. Well, 0 minus 5 is just -5, and 0 minus 3 is -3. So when we go ahead and multiply all of this out, we get an answer of 30. So 0, 30 is going to be our y-intercept. Our axis of symmetry is going to be x equals 4. Our vertex is going to be 4, -2. Our minimum value is going to be -2. Our parabola in this case is concave up. All right, and then let's take a look at our very last one. We do have a y-intercept on our graph, so we got lucky. We didn't have to do too much extra work. So 0, 8 is our y-intercept. Our axis of symmetry is already on our graph because we used it to identify and make our life easier. We identified the vertex. Our vertex is -2, 0, and we have a minimum value, and that minimum value is 0. On our picture, we can clearly see that our parabola is concave up. So that's it for the 4 questions where we have to graph parabolas in vertex form. Oh my gosh, not vertex form, factored form, or it's also called intercept form.